Percussionaire TXP5 High-Frequency Percussive Ventilator. Theory and principles. The TXP5 is identified as a high-frequency percussive ventilator. It is not an oscillator, nor a jet ventilator. Its principles of ventilation lie in the widely used VDR4 and TXP transport ventilators. The control panel allow adjustment for frequency and amplitude that are featured on the multimeter display along with mean airway pressure. Upon initiation of flow and amplitude, small pulses of gas are accelerated down the central lumen of airway with high enough velocity to reach the lowest levels of non-compliant and resistive lungs. As gas reaches the lowest levels of a non-compliant lung, molecules diffuse rapidly, then reverse and swirl up the sidewalls of the lowest airways in a counter-current flow pattern. This effective and highly diffusive action allows for constant and robust gas exchange throughout the entire respiratory cycle without interruption. The key to the TXP5's ability to maintain mean airway pressure at all levels of compliance change is the unique valving system. Gas is entrained to only meet needed set pressures, and the open exhalation system allows counter-current expired gas to exit out. The balancing of only enough gas to fill, ventilate, and maintain safe mean pressure is done instantaneously by this sophisticated system. In this demonstration, we have a standard conventional ventilator, and it is attached to a standard conventional test lung. The conventional ventilator is then attached to a rigid container filled with confetti, emulating a stiff, non-compliant lung. As the bolus convective gas attempts to flow into the non-compliant rigid container, the confetti barely moves. The rigid container is then connected to the TXP5 high-frequency percussive ventilator. Immediately, the confetti circles around the container in a molecular dispersive manner of counter-current flow. This dispersion of gas molecules at the lowest level of the lung allows for optimal capillary gas exchange. Meanwhile, non-injurious mean airway pressure is held, no matter what the size of the lung is. High-frequency percussive ventilation. Device setup. To set up the TXP5, first go to the back of the ventilator and use the gray clip to attach to an IV pole. A green O2 hose is attached to the DISS connector on the back side. Power is connected to the ventilator with the inlet power receptor on the left. On the front of the ventilator, attach the red tubing line to the red connector and the clear tubing line to the silver connector. After attaching the red line and clear line to the TXP5, then attach the red line to front measuring port on the phasotron. Then attach the clear line to the white connector on the phasotron as shown. You now have an example of a standard circuit setup and attached to the TXP5. Standard circuit filtration. Filtration of the open valving system is at the discretion of the user. An HMEF filter is recommended at the patient connection as shown to provide humidity to the patient. A virobacterial filter can be used on the exhalation port. A third filter on the entrainment port is an optional addition if desired. Optional PEEP valve. A clinician can add the optional circuit kit that includes both a PEEP valve and a one-way pressure relief valve. The Percusionaire TXP5 has the ability to add a separate PEEP valve and one-way valve if PEEP is desired. It is available as a separate purchase, as all patients may not require it. The PEEP valve can be added to the exhalation port to create independent adjustment of mean airway pressure while keeping both frequency and amplitude adjustments the same. Adding PEEP requires an additional fail-safe gate valve on the entrainment port to preserve PEEP pressure in the system. Filtration of the optional circuit. Filtration can also be added to the optional circuit. Again, an HMEF filter is recommended for humidity and viral protection. The clinician can also add a filter between the PEEP valve and the phasotron body if so desired. Multimeter display. The multimeter has 6 different modes. For the purpose of this video, we will focus on the wake mode. For further explanations of the other modes with the multimeter, please refer to the TXP5 manual. To wake up the multimeter, ensure the ventilator pressure is greater than 2.5 centimeters of water pressure at the phasotron delivery port for more than 1 second. Once the multimeter is in active mode, the pulse amplitude is displayed at the top right. Mean airway pressure averages the pulse amplitude over 5 seconds and is displayed as the large number in the middle. The high frequency rate is displayed in the box. On the upper left corner, the high and low alarm limits are displayed. Below that, a battery icon shows available battery life. Across the bottom on the left is the menu display. The lower middle window is for adjusting the alarm volume. The lower window on the right is for adjusting alarm limits. The black knob below allows the operator to select which window they wish to highlight and open by pushing on the knob. Opening the menu window allows for power to be turned off. Scrolling down allows for screen contrast to be adjusted. Information on the ventilator can be accessed through the System Information screen. Opening the Alarm Set window allows high and low alarm adjustment. High and low alarms can be adjusted using the black knob to scroll up and down with each one. Pre-use check. Rotate the frequency knob to full clockwise position. Rotate the amplitude knob to full clockwise position. Connect TXP5 to 50 to 80 psi gas source. Connect the phasotron on the TXP5 red and clear connections. With a gloved hand, occlude the phasotron patient port, making sure there is a tight seal. Rotate the amplitude knob to full counterclockwise position. Observe frequency on right side of display around 225 pulses per minute or less. Observe mean airway pressure on display around 20 centimeters of water pressure. Rotate the frequency knobs to the left, full counterclockwise position. Observe a smooth increase in pulse frequency to a rate around 650 pulses per minute. Observe mean airway pressure on display around 20 centimeters of water pressure. Rotate the frequency knob to arrow up 12 o'clock position. Rotate the amplitude slowly clockwise. Observe a decrease in amplitude until off at the full clockwise position. Pre-use check complete. Initial setting with a standard circuit. Once the clinician has finished the pre-use check, they can then attach the circuit to a test lung. The initial parameters to set up with a standard circuit are pulse frequency and amplitude, with mean airway pressure being a measurement of the pulse amplitude. Pulse frequency. This will be displayed and measured on the multimeter. The frequency control will increase or decrease the high frequency rate of the pulses. In general, the starting high-frequency rate for adults is 500 pulses plus or minus 15. The multimeter display will always be the actual parameters of ventilation that the patient is receiving. The second parameter is amplitude. This refers to the size of the pulse and is displayed on the multimeter in the top right corner. The amplitude control will increase or decrease the size of the pulses. Simply turn the control counter clockwise to increase the frequency rate, or turn the control clockwise to decrease the frequency rate. With the standard circuit, the mean airway pressure is a calculation from amplitude measurements and is indirectly controlled by either the amplitude or frequency controls. Now that the TXP5 is connected to a test lung, the general initial settings for an adult are: an amplitude of 30 is displayed on the multimeter. Once the initial setting with the test lung is verified on the multimeter, connect patient to the ventilator and look for a gentle wiggle. The larger the adult patient, the less wiggle one will see. If there is a large chest wiggle, decrease the amplitude by 2 to 4 centimeters to achieve a gentle wiggle. If there is no visible chest wiggle, increase the amplitude by 2 to 4 centimeters until a gentle chest wiggle is achieved. Initial settings and adjustment with optional PEEP valve kit and oxygen adapter. The initial settings are the same with the optional PEEP valve kit. The difference now is that there is individual adjustment of the PEEP, which directly affects the mean airway pressure. To increase PO2, the first step would still be to increase FiO2 using the oxygen adapter port. The next step would be to independently adjust PEEP with the PEEP valve by 2 centimeters. This would be measured on the multimeter with the mean airway pressure increasing by 2. The last step for trying to improve PO2 would be to increase the frequency rate by adjusting the frequency control up to a high of 700. These are the simple options for PO2 adjustment with the optional PEEP valve kit. To decrease CO2, we would increase amplitude by 2 to 4 centimeters. But if the mean airway pressure increased and we wanted to keep the mean airway pressure at the same level, we would then decrease the amount of PEEP by adjusting the PEEP valve to keep the mean airway pressure the same. In this example, the amplitude is around 30. We would then increase the amplitude by 2 to 4 centimeters to 34, and then also adjust the PEEP valve if needed to keep the mean airway pressure 18. These are the advantages that a clinician can have with the optional PEEP valve kit when attached to the phasotron while using the TXP5.